This is the supplemental lecture for chapter 3. So today we'll focus on mathematical reasoning and problem solving to show you how to be a better problem solver. All right. In this chapter, there are a couple of problems that may not seem applicational at this point, but when you take the corresponding Math 107, that's where you learn the application more. So that's why we're focused on problem solving. But I'll give you a tip that can be useful, right? If you're tired of problem solving on math, which discourages you, then I would encourage you to treat it this way. Think about the math problem as a game puzzle, like a puzzle in the Candy Crush, right? The puzzles will be more and more challenging as you progressed, but, well, you earn a sense of achievements when you beat the level, right? So think about yourself to be trained as a professional gamer or something like that, right? And then your goal is to solve all these puzzles, these math puzzles. And then today we're going to decipher the language and see what we are actually solving, right? So example 1, solve for x. One of the questions from chapter 3. And right, when we see this, that means we're finding x. We're trying to figure out the value of x. Sometimes you'll get a numerical answer, or sometimes you'll get an answer in terms of other symbols like y and z. Well, that's because x, y, and z's are variables. So our goal is to isolate the certain variable like x, and then make sure the other variables are moved to the other side for problem solving. So this is like a game rule you should know. And if you know how to play with such a game rule, and if you know what's going on, then doing math will be more fun, right? And if you didn't do well on a certain problem, if you fail to solve one, it will motivate you to solve more and more, just like how the Candy Crush works. Or Angry Bird, that's another good one. Okay, let's proceed. So how do I solve for x? So I'll translate that sentence in another way. So what we're doing is to isolate. The keyword is isolate. We isolate x on one side of an equation. Right, so what is an equation again? Equation is a line with something equals to something. That is an equation. And then that's our goal. Our goal is to make x equals to several terms on a certain side. So we have, for example, we have negative 7x and negative 4x on both sides at the beginning, right? So we want to make sure the x term disappear on one side. That's what we were doing. And then one way to do that is to add or subtract something on the entire equation. So for example, you should have seen this in the lecture video before, that if you operate by adding a certain like terms, then you're able to eliminate the like term somehow, like minus negative 7x plus 7x that equals to 0. So that's why these two terms cancel, right? Right, so besides doing that, yes, that's one way to approach, that's one step to approach the answer. But I'll tell you what, there are more we can do on this expression. We can add 5y on both sides of the equation. No, that's not what I want. We can subtract 7y on both sides of the equation. And why do we do that? Because I want to eliminate 7y so that I can make sure the x term will be the one remains on the right-hand side. So x terms is already gone on the left, right? And then I can also subtract 2z on both sides of the equation. So that's the operation on both sides for you to eliminate 2z. So according to what we learned, what do we get? Right, we'll have negative 12y plus minus 2z plus 4 equals to just something x, right? Negative 4x plus 7x equals to what? Think about it. Right, 3x. And that's what we have so far. Okay, what do we do next? Right, I'll let you pause the video and think about it. We have this chunk equals to 3x. So what should we do to isolate x? Think about it. All right, assume that you have paused the video, then I'll show you the answer. We divide the equation by a certain number. And remember that the rule shows that we have to do it on the entire left-hand side and right-hand side. So that's how it works. The 3's are divided out in this way on the right-hand side, and that's how we approach the final answer. So that's what we do when we see the keyword solve for, right? If you don't have other variables like y or z, then your final answer would be a number, right? So x equals to that huge fraction. That's the simplified, that's also the simplified form we have. So problem solved. All right, let's check out another example with fractions in an equation. Solve the equation for r in terms of s and t. Okay, now we have to know another game rule for this Candy Crush Plus puzzle. Right, so what do we mean in terms of? Sometimes the question was stated, sometimes it doesn't state it. Right, doesn't make a difference. The stating will be more clear then. Right, so we need to isolate r, solve the equation for r. That's what it meant. And then when we find r, then we need to make sure the equation at the end include s and t somehow on the other side with no r. So that's what the phrase in terms of means. Right, so make sure you understand the keyword when you study math. Ask yourself, what does solve means and what does in terms of means? Right, if you can decipher and then if you first understand the grammar of math language in this way, including the use of English, of course, then it'll help you do math better. All right, let me do an example and then you'll see how I approach the final answer. Make sure you practice it on the homework. All right, so we have this equation s over r minus 1 equals to t over r. So we have to isolate r and make sure no r is on the denominator. And then this is a good one for you to think about. So pause the video and think about what to do next. All right, assume you're done, that you're actually done. I trust you, so we'll move on. What we'll do is to multiply r on both sides of the equation. And why do we do that? Because if we do that, then we are able to expand this term. Then we'll get s minus r. Get it? Right. Remember, the symbols s, r, and t, they're actually all values. We just don't know the values yet, so that's why we use the symbol to present them on an equation. All right, Then on the right-hand side, r, so I divide it out, and then we have t only. And now the rest becomes straightforward, right? So to isolate r, what we can do is there are more than one way to approach the answer, but one thing we can do is to take off the s on both sides of the equation. So remember, when you manipulate the equation, you do the same thing on the left-hand side and the right-hand side, okay? Right, then we'll have negative r equals to t minus s. All right, and one thing we know on math is that we can flip the sign on every single term to get the right answer. So if I flip the negative sign and the positive sign in order, then we will have positive r equals to negative t plus s. So the sign in front of the t, if there's no negative sign given, then that one is essentially positive. So that's why we can flip the sign in this way. R equals to negative t plus s. So now you see how the answer is like. R, solve for r, we isolate r on the left-hand side, and then that equation of r is indeed in terms of t and s. Are t and s included on the other side? Yes, they are. Right. That's what the language means. All right, so in the future, when you see we're solving for x in terms of a, b, and c, now then you'll know what's going on. Okay, right. That's the part of the mathematical reasoning. You have to grasp the language and the right grammar. All right, example 3, find the slope and the y-intercept of the line. All right, this is a different type of problem. All right, so we have to understand what slope means, right? This is a linear graph plotted by data for us to present some real situation. But again, the application will be in Math 107. So let's focus on the theory here. All right, slope, again, stands for the steepness level of the line given, right? So I'll find a slope in this example first, and then I will show you a counter example. Sorry about that. All right. So one way is to pick 2 data points. And then I will normally recommend picking one that intersects the axis or the one that intersects the grid line. Why? Because that allows us to find the steepness level of the line. You can pick any data point, but these 2 are 2 sample points, which helps you find the answer easily. So we learned that the slope, the symbol for the slope is m, right? And then the general equation of the slope equals to rise over run. So rise is the vertical change of the variable y on the y-axis. So if we have the data point right here and right there, then the rise will be like that, right? And then the run will be the horizontal change of the variable x. Right, that is what rise over run means. And then we also have to figure out a coordinate, the data value on 2 points. So for this data point, we will have 4, 2, because the 4 is the x value and then the 2 is the y value. And then this one will be negative 0 and 0, -1, because that's the y-intercept. When x equals to 0, then y equals to -1, as indicated by the intercept right there. All right. So we can now see that, right, rise over run, the change of the y direction will be, right, this value minus that value. Okay, so that will be 2 minus -1, right? The final y value minus the initial y value. And then for the run, that will be under info, that will be this x value minus that x value. So that's 4 minus 0. Right. Then what would the answer be? That would be 3 over 4. So that is your slope. All right. I'll explain why that makes sense. So if I count the change in the x direction, right, what is the increase of the number? Does the number increase by 3, 4, or 5? Well, yes, we have number increased by 4, and that's what the run tells us. And then the way we find that by math is to subtract the final value and then by the initial value, right? And then in the y direction, we have the number increased by 3. So that's your rise. Rise equals to 3, run equals to 4. And then the y-intercept is defined as b, and then that will be -1, because that is the y value when x equals to 0. So remember, the line can be presented by the linear equation as y equals to mx plus b. And then that b is the y-intercept. So problem solved. All right, I promise you I'll give you another examples of a slope. So let's do it. So let's say that I want to create a line from here to there for the lecture purpose. All right, so that is the line. So this is line number 1 and this is line number 2. All right, here's a question for you. How does the slope compare between these two lines? So we have the slope as m1 for the red line, and then we have the slope m2 as from the green line. So which slope is greater, m1 or m2? Well, first of all, it's m2 because the line number 2 is steeper, right? It's steeper. And then if you try to imagine that, right, something is trying to move uphill, then the second line will be harder to climb in the real situation. So the steepness level is greater for the line m2. For the slope of line m2. So that's what the slope tells us. Make sure you understand that concept. All right, now we have another example. Example 4, determine the slope of the line passing through the points. All right, I have an idea for this question, so let me show you. I'm going to borrow the previous blank graph, and then I'm going to use that blank graph to show you the way we approach the answer, okay? In that case, I can move to example 5 backward. Right, so determine the slope of the line passing through the points. All right, so we have 2 points given. -4, 4, that's the point in the third quadrant, which is right there. And then we have, oh, no, -4, +4, that should be this one, right? And then another data point is 3, comma, -7. Then that would be the fourth quadrant because we have positive and negative value in order. 3 and -7, right? That's how we trace it. And we do the same thing for the first point as well. -4 and then +4. That's how we visualize the info. And then if we have these two data points, then we can definitely draw a line between these 2 points. And then it will be something like that. Well, I'm not sure how my point get messed up on this example. So let me use some trick to fix it. Guess that linear function doesn't like it. So I'll just draw the line physically. I'll make sure the line is as straight as possible. All right, here we go. All right, so that's the line in the example number 4. So to find the slope, we apply the rise over run method. Right. So this is the initial point, and then this is the final point. Right. So we normally trace from the left to the right to get the initial and final point. All right. So for the rise, we subtract the 2 final y value, which is this one and that one. Okay. That would be -7 minus +4. All right, how about the run? Run equals to final x value minus the initial x value. We are finding the difference. And that's how we see how the variables change on graph. And then, the steepness level will be found as a numerical answer. 3, and then 3 minus -4. And then the answer will be -11 over +7. Right. So the slope is negative. And how do we know if the slope is negative? Right. One way to tell is that if we know the rise, if we know the run as the horizontal change of value, then we can see that the run is +7, right? The data value is increased by 7 to the right. And then if the rise is directed downward, then that's like a negative change. It's like a negative rise because rise normally means up, right? So if you're tracing the y value downward, then that's how you tell the sign. Your sign of the slope will be negative in this context. Right. Problem solved. All right, example number 5. Find an equation of the line that has a slope of 7 and a y-intercept of 0, -6. All right, this one should be more straightforward because we just have to apply we just have to start with the generic linear equation. And then the question is nice enough because they provide the linear equation for you to start. So it is important to know that when you have a question given like that, the slope is normally m, which equals to 7, and the y-intercept would be the y value, which is called b, right? The data point that passes through the y-axis. So intercept means passing through, right? That's what, that's my point, exactly. Then plug in m and you plug in -6, then that will be the equation of the line. That's all you need to do, right? Y equals to 7x minus 6, problem solved. All right, last example, give the slope and the y-intercept of the line. And then this one is a bit tricky, but it's doable. Right. If you don't know how to start, then I'll show you. Right. We have to isolate y on one side of the equation. Right. And then this is a good chance for us to see how to read an equation. So if you have y equals to mx plus b, then that means your dependent variable y is the certain outcome value when you plug in a certain value of x, when the slope and the y, and when the slope and the y-intercept are given as a fixed value. So y depends on your outcome value. Y depends on the x value you entered. So if you have an equation with something like y on one side, then that means we are determining the value of y depending on what x is given. All right, so that's why we have to arrange this equation. Right, so first of all, we have x term and y term on the left-hand side. So the first thing I would do is to remove the x term, because when we do the algebra like that, then we are going to add the same term on both sides of the equation, right? We do that to eliminate the x term on the left. So we have 3y equals to 9 plus 9x. Right. When the y term is alone, then we can operate by the division. So dividing both sides, the entire side on the left and on the right, divide the equation by 3, so 3 are divided out, and then we'll get y equals to 9 plus 9y over 3. And then this is the chance to practice this simplifying the fraction, right? So if I have this expression, then we can tell that there is a common factor for us to apply. So we can multiply the equation by 1 over 3. I believe other instructors have a different way, but if we do that, then we can eventually get the answer as 3, because we have to expand this term, right? 9 times 1 over 3 gives you 3. 9y times 1 over 3 gives you 3y. So we have 3 plus 3y over 1 when the 3's are divided out on the denominator. And then if I rewrite the equation again, then this will be that should be x. This should be x, this should be x, and this should be x, right? So the final answer will be 3 plus 3x. Y equals to 3 plus 3x. So I shouldn't say this is the final answer yet. Right, I want to rewrite that equation again, because our final goal is to figure out the m and the b. So this is my m, this is my b. So it appears that the slope equals to 3, and then the y-intercept equals to 3 as well. All right, Now the problem is actually solved. All right, make sure you practice on the homework and get ready. And then practice more similar questions to make sure your math reasoning improves. And then that's when you are ready to take a quiz. I'll see you next time.